In this session, we'll discuss how Python can interact with databases, and in particular, relational databases, SQL databases. And these are important because most data in banking and finance is stored in large relational databases. And to see why, we can look at auto loans or mortgage loans. And generally, these have each loan will have a unique key. This is the relational, how you can relate one table to another. So each loan will have a unique key, and then we'll have loan application details, which we can link to other tables that'll have the loan payment details. So these are how loan information is generally stored. So what we're going to do here is we're going to look at, okay, well, how can Python interact with this database? In particular, how can Python request that the database does some computations and returns the data to Python? Before we jump into a little bit of the code, if you'd like to see a very interesting analysis that employs its own SQL database, we have links here to this blog post, which does an analysis of Fannie and Freddie mortgage loans. All these are public now, Fannie and Freddie loan level files. This is all loan applications and performance files, which have each payment for each loan. So this is all made public by any loan securitized by Fannie and Freddie. So you can take a look at this post and the actual code here, which gives you a little bit of idea of the databases used and how they are used and so forth. Lastly, before we start, note that there are other types of databases, and we'll discuss them, and Python can interact with those databases, but here we're going to focus on SQL. So we're going to interact with the database using pandas. And the actual connection will be made by a package called SQL Alchemy. So we'll import the Create Engine module from SQL Alchemy. And what we're going to do here is we're going to go ahead and create our own database and then query our own database. So first, let's go ahead and get some files that we're somewhat familiar with. We'll pull the weighted average cost of capital table. And what we're going to do is, now that we've created this engine here, so what this does is it says, okay, it's creating this SQLite database. Now, SQLite is as the name implies, a SQL database, but it's interesting in that it can run in RAM here. So what we're doing, it can be saved to disk, but we can also just run it in RAM here. SQLite databases are ubiquitous. To give you an example, much of the information, if you have a web browser like Firefox, is stored in a little SQLite database. So you've used SQLite databases even if you don't know it. So all we have to do to create a table, so now we have this pandas data frame, and we're going to push this onto the database as a table, and we can use this toSQL function. Here's the pandas data frame that we're going to push onto the database, and here's the connection. So we can go ahead and do that, and then we can list the tables on the database, and we see this weighted average cost of capital table. So now we have a table on our SQL database. The most important thing that you'll do as an analyst is run what are called select queries on the database. And what this is you have the database and you are going to pull data from it. And this is important, keep in mind, because this is the first step on any of your analysis, right? So if you're going to do, you're a financial analyst somewhere and you're going to do an analysis, let's say try to look at what states where loans loan delinquencies are increasing or so forth. The first step is going to be a select query in your in your analysis. So this is generally how all of your analysis will start. So to run a select query, all we do is here is the actual SQL code, right? This is a different language than Python. So here we have Python. This is our database connection. We're going to say execute this bit of SQL, right? And then what we're going to do is return it as a pandas data frame. So what this says here is select everything from this table, the WACC table, where beta is greater than 1.2 and the cost of equity is less than 0.07. So we can go ahead and do that, and it will return every column, but for only those rows which match this criteria right here. A couple things to note about this SQL: the capitalization does not matter. However, so in other words, it is convention to write it uppercase, but I can write it lowercase, and it'll be perfectly fine. However, and this can be different. This is in SQLite, and there are other SQL databases: PostgreSQL, MySQL, Microsoft SQL Server, and things can be slightly different from database to database. But something like this backtick that we have here on cost of equity, this is sort of mandatory. If I were just to put that into a single quote, see, it gives an error. So it is not case sensitive. However, it is definitely sensitive to whether that is a backtick. That's right below escape on your keyboard. So we can go ahead and run that. Now, one of the things you might be thinking at this point is, well, what I could do is just have this whole table, and then do this filtering in pandas. However, keep in mind, most of the tables, or you might be dealing with a table that is very large, right? So that would be extremely inefficient to actually just pull all the data and then filter it in pandas. So the benefit of what's going on here is the filtering and the computations are done on the database where it is efficient, and then it's only transferring only the data we want to Python, right? So again, pulling everything and then filtering in Python is fine if it's a small table, but as the tables get larger and larger, that becomes increasingly inefficient. So we can also do other, we can select single columns if we'd like. Instead of saying select all, we can simply say select cost of debt there. We can select multiple columns, obviously. What we can also do is do some simple aggregation or calculation. So if we just wanted to know how many rows does meet this criteria in the weighted average cost of capital table, how many rows meet this particular criteria, we can use count here. As we'll see, it should be about 7. There we go. And we can also do some simple calculation. So if we wanted to say, okay, now this calculation from a finance standpoint doesn't make much sense, but if we wanted to sum, I guess was this cost of debt was right here. So let's say we wanted to know this sum, right? So we could say sum the cost of debt where for all the rows that meet this criteria, and that'll give us the sum there. So we can also calculate average and so forth. So simple metrics. So this gives you a little bit of an idea of what we do with SQL, but also that we can call this SQL from Python and then have the data return nicely into Python for analysis. Lastly, we just have one table in our database. Let's pull a couple more tables. Now this is much less, you are much less likely, so we're pulling this tax table and a debt table, so here's all the columns. And we can put these tables on the database here so that now our database should have the weighted average cost of capital, tax, and debt tables, so it has 3 tables. Now, again, very often you'll be writing select queries. Sometimes those select queries will actually join tables, right? So if I wanted to say, if I have a loan database and I want to say, okay, well, select, and I probably wouldn't select all, but I want to select a loan application table and match it with a performance table. So I could join tables in this way. So this is going to join all three tables, and then so this is the actual query, and then we're going to execute the query here. You can so now we have all tables, all these tables merged, right? And you can see it's repeating itself. So it's an inefficient query. We want to get rid of the duplicate columns, but another thing to note here is that it's often very convenient when queries get sort of long to separate them into a separate line. And then, so this is right here, this is just a Python string. So we can give the string a name and use that name here to execute the query. So this is sort of an efficient workflow. Lastly, what we've done here is we've looked at how Python can interact with the SQL database. There are now that there are increasingly other types of data that are often stored. There are key value or document type databases. These started with storing information like a social network might store. A SQL database will tend to if you want to add a piece of information, you have to add another column, and then if you only have that piece of information for very few rows, it will have NA and all the others. So we have different types of databases that they can generally have, each document can have different columns. So we have other types of databases, Couch database, this is Mongo database, MongoDB, and Python can interact with these just as well, though I won't cover it here. They're less, as a financial analyst, you're much less likely to use those. So as an exercise, select only the tax rate column from the weighted average cost of capital table. However, keep the constraints where these are the constraints that we have been using. And have your query calculate and return the average tax rate. So what we would like, and this calculation makes a little bit more sense than the previous one, we'll calculate the average tax rate for all of those rows which meet this criteria.